Okay guys, in today's video we're going to be looking at a dead set condition on a Toshiba Regza TV. Doesn't power on with the remote, doesn't power on from the side power button. If you're handy with the soldering iron, stay tuned. I'm going to show you how to fix this. We've got this TV off the wall and I've just set it on a couple of ottomans for now. No, it's too big obviously to bring out to the bench. We need to get the back cover off. You're going to remove all of the screws that have one of these arrows next to them. Right? So I'm just showing you some examples, right? So only the screws with the arrows. Now, some of these screws are kind of small, like here's a guy inside here. Hopefully you can see there's an arrow mark there. There's another arrow mark here. There's an arrow mark here, right? And then all along the perimeter. If we take a look at one of the little service bulletins for this from Toshiba that we're going to be using today, you can see, for example, this is a 55 ZV650 series. You have all of these screws. They show these ones in red going all the way around as the shorter one, and the ones in the corners are a little longer on each of these sides. But what they don't show on here is that underneath these wall mounting brackets that you would have put on aftermarket, you'll find two underneath there as well. So when you take these brackets off, you'll find two more screws to remove. So we're going to remove all these screws, and then we're going to lift off the back cover. All right, once you get the cover off, guys, you'll be staring at a picture like this if you've got the 55-inch, and then, of course, scaled down if you got one of the other models. This green board over here is the main board. The board we're probably interested in is this brown board in the center. This is the power board. And the first thing I do when I get a problem like this is I just kind of do a survey of the whole board, looking to see if I see anything obvious. A couple of things that jump out at me. I see a couple of fuses. I see one here and one here. We'll try that first just to see if it's something easy. And then I'm just going to investigate all the components. And so if I take a look with a flashlight and I kind of go over here, one of the things that caught my eye was there's some burn marks around this resistor here. And don't worry about my finger being in here because it's been powered off overnight. And then there's another resistor here that's got some burn marks. So it's fairly easy to tell if those resistors are okay because they got a color code on them and we can ohm them out. But I don't really think that's why we don't have any power. So we're just going to start debugging this. I'm going to set this flashlight kind of over here. And the first thing I'm going to do is check these fuses. I'm just going to do that with a simple continuity test. I don't expect them to be bad, but we'll check them. This guy's good. This guy's good. All right, so the next thing I'm going to do is I'm going to set this voltmeter on voltage. And I'm going to connect the power up now. So with the power connected, remember there's a risk of shock. So once you connect the power, you want to be very careful. Now, if we take a look at the little service insert that we've got here online from Toshiba, and what I'm covering here today covers all of these model Toshiba TVs, not just the 55. And we can see that they have a little diagram here where they tell you if you got a dead set, check for 5 volts on connector 90 on the main board. Yes or no. If no, then you know it's a power supply module problem, which is this brown board we talked about. Yes, you check for 3.3 volts at pin 2. So if you want to see where these connectors are, they're over here. This guy here is CN90, and this guy here is CN91. But rather than, and by the way, the little white arrow on the board and the little white wire would indicate the first pin. Rather than actually checking this, because they don't diagram out where the ground is, I'm going to take this from the power board over here, and we're going to see if we've got 5 volts coming off the end, because on this particular connector, we can see it's been identified, ground and 5 volts. So we can just come in here, get the meter over here so we don't have to spin the camera around too much. And come in here and we'll check and see, do we have 5 volts? And I didn't expect we would. If we look at the meter, we got nothing. Wiggling these guys around and making good contact. You know, if you wiggle them around a little bit, you get a little bit of a twitching of millivolts, but we got no 5 volts. So at this point, I don't even have to check the rest of the flow chart. We got a power supply problem. So I'm going to continue to leave this set to voltage, and we're going to come over here and we're going to see, do we have power coming in from the wall outlet? And the way I'm going to check that is I'm going to come in here. I'm going to leave this set to voltage. It's going to pick up the AC volts. You can look in here. See that it slipped up on me. Now she should be auto ranging for me, but she's not. 124 volts AC. So we are getting power in. So we know we're good from here to here. So if we continue to look at this circuit, what we're looking for is a bridge rectifier type device that will convert the incoming AC power from alternating current to rectified plus and minus voltage. And the first thing that catches my eye is this big heat sink over here. And sure enough, if I look over on the side here, we see an indication for AC in and plus and minus out. And you can kind of look on the side here and see the numbers on this particular device. And we can see that it is a DXB40 type of inline bridge rectifier. And so what we're going to do is we're going to see if we're getting AC voltage to this guy. Now remember, this is still energized, so I do want to put a couple of gloves on here, just in case I don't want to get a nasty shock from one of these capacitors in particular. Then we're going to go check that voltage. All right. So we'll come in over on here. Come in over here. And we go look at our meter. And we should be seeing AC voltage. And we're not. So we already know it's not the rectifier itself. It's that we're not even getting alternating current supplied to the rectifier. So that should make it a pretty straightforward repair. We're going to take this board off, we're going to flip it over, and we're going to trace out what is our path from here to here, and see what component has given out that's causing us not to get power into the rectifier. So let's go ahead and do that. And the way we're going to do that is we're going to take these screws out that are along the perimeter. I recommend that you leave the one that has the ground tab here to last. You want to go ahead and disconnect the power from the mains, which I've just done here. Even after disconnecting the power, these big capacitors are going to store that electricity for a little bit, but they'll begin to gradually discharge. Just have some kind of protection on, or let it sit for a while, several hours, and go ahead and pull these screws out. And then we're going to remove these connectors at the end after we pull the screws. I recommend you take a picture just so you can remember which one goes where. They do have little markings, at least on mine, so if you take a picture, you'll know which one connected where. Anyway, we're going to go do that, and then we'll come back. All right, guys, we got this out here on the bench, and what I'm going to show you is how I determine the parts that I'm going to look at here. So remember, we're not getting AC voltage to this rectifier here, this bridge rectifier. I'm going to flip this board over. This would be our rectifier, and Toshiba has conveniently shown us the plus and minus and the input for the AC. I'm going to once again set my meter for continuity testing, and we can just start going over here, right? So from here to here, we've got connectivity. Now we don't have connectivity here because this is not a populated component, but we do have jumpers here and here giving us connectivity. We get connectivity then down to here, and then we have no connectivity here. So if we take a look at that, what we see is exactly what we just measured. These two components are not populated, so there's jumpers provided, and this component here is not providing any continuity. Now if we zoom in on it, what we see is it's a 1.8 ohm, it looks like a ceramic type resistor, but it's actually a fusible resistor. And we see two other similar ones here and here. So we're just going to check those just to make sure that the behavior we're seeing is the same. So here and here. So if I flip this over again and look at those two components, I can see that I am able to get continuity here and here. And also, if I switch my meter now to measure resistance, pull this a little closer for you guys. Yeah, there we go. I can see that I'm actually able to measure that this guy is providing just around 1 ohm. And the guy over here, similarly, is providing around the same. But our suspect, when we measure him, we're getting nothing. So that's the guy I suspect is the problem, and we're going to pop him out. Now, when I went and looked this up, this part number that you see on here, I can't find it made anymore. But I did find a replacement part that's an equivalent. And the equivalent for that guy is going to be a 5J2R0. And if we take a look at this guy here, set him over here, and we try to take a look at his resistance. When we look at our meter, we can see he measures in around 2.5, 2.4. It's kind of floating around there just because my hand's probably moving a little bit. So basically 2.5 ohms. And the original rating that we saw up on this guy was 1.8. So that's close enough. So I'm going to remove that component and replace it. But I'm not done yet, because we got to figure out, why did this guy burn out? Well, the next thing, if we keep tracing out on our board, the next thing we find as we go over from this component is this relay. And so I would suspect that this relay is what eventually triggered the problem that led to this guy burning out. A couple of reviews on various TV forums, and I find that this is suspect of getting dirty contacts. So we're also going to pull and replace this relay. Now, one of the things about this relay, this is a 5-volt Omron relay. And very similarly, when I've worked on these kind of Omron switches on mice, right, you get a lot of Chinese clones. So to make sure I'm getting something that's going to match up for me, I go pull the data sheet from the manufacturer. So this is an Omron G5PA TV relay, right? And so what I'm interested in doing here is I'm interested in taking a look at the specifications of the 5-volt one, and I can see that the coil resistance is 100 ohms. So what I'm going to make sure of is that I got something. I don't really necessarily care if it's a knockoff, but I need it to be the same rating. So I'm going to come in here and I'm going to measure the coil resistance. And I can see I'm reading just under 100 ohms, 99.8, which is close enough. So this is basically meeting at least the coil resistance of the data sheet and matches the voltage specification. It also matches the part number that we see if we take a look at the board. Flip this guy back around again to where you can see it on this side. You can see this is this guy we're after right here. It's G5PA1 5-volt Omron made in China relay. So we're going to pull both of these components, and I suspect that is going to get us back in business. Now, there's a number of ways you could pull these. You could use like a sucker tool, or you could use like, I'll show you a tool like this. Tool like this particular type of soldering iron, where you can kind of suck the solder out. I do a lot of this, so I'm actually going to be using a more professional setup here, where it's got a built-in vacuum. So we're just basically going to pull these two components. I'm going to pull this guy that we already identified is no good. So when you're doing this a lot, it just makes really quick work for this kind of stuff. And then we're going to pull this relay out of here. This guy's got a lot. Big ground kind of sink, perhaps. I'm going to give him another blast just to be sure. Put it back a little bit like this, just to kind of let gravity help us a little bit. And I'm going to go give this guy another whack too, because I didn't like how he looked. Hopefully, and we got the side off. We just have a little bit on this side still holding. Sometimes you get that where there's just so much on there that you might have to get in there with a regular soldering iron. I think that's what I have to do. Yeah, I've got 3 out of the 4 of these, but this guy up here on the top has got a lot of excess flow solder on the upper side of the trace. Let's see if I can get him melted just by holding it here. Don't know if I can, though. If we look up on top, 3 of them are released. It's just this 4th guy. It's not able to get him off with the desoldering gun. So I'm just going to use my regular iron. We'll come back, we'll pull this guy out, and I'll show you putting these in. Alright guys, we finally got this heated up enough where I think she's going to let go. It's just a lot of current to sync with this particular pin. There we go. Alright, so we've got our old one out. So what we'll do is we'll clean up these connections and then we'll install our new component. So we've got our old resistor and then we've got our new resistor here. Just make sure we get it in the same orientation so we know that the writing faces the front. So we'll sit it like that. Hold it down with one hand, tack it down, then we'll do the other side. And then we'll come back and we'll do the same thing with the relay. So what I'm going to do before I do that, though, is what I'm going to do is I'm going to show you, we're going to open this relay up just to see if we can see what may have happened internally. You can probably even clean these. So just like with the Omron mouse switch relays, these TV relays also have like a little latch here. If you can get a small enough tool in here, I'm sure we can get this open. Hopefully this one's small enough. Not sure though. Might not be. I might have to find something smaller. So let me look around so I can have something smaller. Alright guys, we're just going to tack this guy on here. And with one side tacked on, we can do a better job on the first side. All right, so we've got that guy back installed there. All right. And then we're just going to check him out. Actually, our meter decided to go to sleep on us. Okay, but now we're reading resistance. And we got our... going to have a little bit of extra resistance from the rest of the circuit, I'm sure. We get continuity. All right, so the reason we had such a hard time getting this relay out of here is he's held in with a couple of steel eyelets. So just this type of board, right? This is not a traditional kind of printed circuit board on top, right? So you've got a silk screen and PCB mask on the bottom, but on the top it's kind of like, you know, old school 1960s, 1970s stuff. And those eyelets just drew a lot of current for us. But we got that cleaned up so we can put this in here. Before I do that, we also got the old one where we could get it. Well, we had it. And of course, epic fail. Closed it again. But I think I can get it back open again. I'm just going to bust it because I don't really care. I'm just trying to show you guys what's inside. Like I said, you know, if you're more careful with this, you might have some luck cleaning it rather than replacing it, but it's not an expensive part. But there's what you've got inside. Is you got a coil here. And when the circuit wants to activate this, it's going to end up making contact here. And what you can have happen is you can have this, if we zoom in on this, you can have this get oxidized. You can get situations where this guy sticks for a while, or even material that causes the connectivity to be impeded. But if this guy were to stay on longer than he should, that could be a good reason for burning this out. And so it's a cheap part. We're just going to replace both so that we don't have to yank this thing off the wall again and go through it all over again, right? So you only want to do the repair once. And I don't mind putting in an extra part if I am suspicious that it may have something to do with why the original part failed, right? Because you got to ask yourself, why did this part fail? And you got to do enough analysis to see what might be involved in that. All right, so I'm going to go ahead and solder this guy back in. But before I do, just want to remember we did our visual analysis. We noticed that these resistors looked kind of burned. But we go and try to ohm them out. And we see that we're reading about 45.2 on this guy, and this guy over here, we're reading 47. Just going to take another read on this one because I would have expected them both to be very similar. Just a little bit off. But if you do the color code, it comes up to a 47 ohm resistor with a 5% tolerance. So they're not burned out. They're probably sinking a lot of current in some situation. Could even be related to what we just repaired. I'm going to leave them because they are reading within, the kind of spec that I would expect for this. And we're going to see if the two changes we made over here are enough to get our voltage bridge rectifier putting out the right voltage, which then should complete the rest of the circuit. So I'm going to solder this guy in, and we'll go ahead and put it back in and put it back on the TV and see where we're at. All right, guys, we've got the power board back installed. We've got all of our screws back in. We've reconnected all of our connections here, and our main power here. Put them back in the retaining loops. And at this point, we're going to hook it back up, and we're going to see if we either have fixed it or at least we make some progress. I mean, certainly at this point, we should get voltage now, AC voltage rather, heading into this bridge rectifier. And if these two components were our only problem, we're done. If not, we'll have to continue debugging to see how much further we've got. All right, so I should be able to, over here, even without even doing anything, I now see a green LED lit on the main board, which tells me we are definitely probably supplying the correct voltage now. I'm just going to go ahead for broke here and hit the power button. I now see that, if you can see in here, we've got a red LED lit up inside this device here for the, the optical audio. There's a little laser guy in here. So I think that if I was to shine a mirror here, yep, we've got our power LED lit. Hopefully you guys can see. So I think at this point we have power again. We certainly have restored the power problem. I'm going to go ahead and hook it back up to the signal and see if everything is working okay. And then we'll come back and wrap it up if it is. All right, guys, everything looked good. But I want to show you, just coming back, we're going to go ahead and go over everything with the meter just to show that now we've got the readings that we expect to have. So we're going to start back up here at this connector the way we started, looking for our 5 volts DC. Just got to be real careful that you can actually make contact. All right, there you go. So we got 5 volts DC at this connector. And what we were doing here, remember from our flow chart yesterday from Toshiba, right? We're checking for the 5 volts DC that should have been at pin 13 of CN90 because this is where that is sourced from, over to that CN90 on the main board. And so at that point, we could also then check to see if we got 3.3 volts, but we didn't have that problem originally. We just didn't have the 5. So I'm going to go ahead and skip that part because I think we're good there. And then I'm just going to come over here, put the meter on AC, and I'm going to make sure that now we are getting what we expect to our bridge rectifier. All right, you see over here now we are getting our 122, 123 volts AC, which is what we would expect. And then if we take a look at the output of that guy, and this is polarized, so you got to make sure you get positive and negative. You can see he's outputting just under 44 volts AC that he's rectifying. All right, so if we had not had this work and we still needed to do something else, the next thing we would have taken a look at would have been right over here. This little guy on this heat sink instead. And I'm going to show you a data sheet for that. So even though it didn't apply in my case, it's another thing that can go wrong on these particular models. And what this guy here is it's a STR Y6456. And it's a power IC. And if we swing over on this side and zoom in, we can see that that's the number on this particular chip that's mounted on this heatsink. And so if we still weren't getting 5 volts, this would have been the next thing to check, along with this other semiconductor here, which you can see this is another type of bridge rectifier where you've got AC going in and plus and minus coming out. So these would have been the other 2 components to check. I'll put links to these data sheets in the description. And then one other thing I mentioned earlier, just to show this, this is the actual data sheet for the part that we replaced, the fusible resistor. And I've just kind of highlighted in yellow here, it's going to be green, green, yellow, whatever, the RGDU5M, which is the particular one that this TV used from Toshiba, and then the 5E, which is the fusing temperature code. And what you can see if you zoom in on this diagram is what you've got in here is a wire round resistor coupled with a thermal fuse inside of a ceramic case. And so it's both a resistor and a fuse, a thermal fuse, and at the same time. So I could not locate a source for this product from Noble Electronics, even though they're still around in Japan. But the one we used is a suitable replacement, and I've seen a lot of people in forums have good luck with the part. And again, I'll put that in the description. So let's get this guy back up on the wall and make sure that he looks good, and we'll wrap it up. All right, guys, we've got it up and running. I've let it burn in for several hours. It's looking good. It was a good repair. If you found this useful, go ahead and hit that like button. I hope that if you have any comments that you have other ways of doing this, or maybe you have some questions about how you did this, go ahead and leave them below and I'll try to help. Otherwise, if you found this kind of content useful, please think about subscribing. Thanks for watching.